got it. Okay, so now we're going to try to do a couple of actual examples. Now, what the plan is at the moment, I'm going to do it in Windows. And for those of you who have the setup on Windows can follow along to the greatest extent possible. I'm not entirely sure how that's going to work, but, right? On the other hand, if you just say, I'm going to sit back and enjoy the show, there's nothing wrong with that either. So I'll go through, depending on how the time goes, anywhere from 1 to 3 exercises. And then we're going to take a break, and Richard's going to pick up, and he's going to do additional exercises, but he's going to do it up in the cloud, just as you saw yesterday. So you'll putty on up to the Amazon cloud, and you'll work up there. So that said, let's see what we can do. I'm really going to regret not having my eyeglasses for this, but this is life. Okay. So I have a directory, I think yours is called something a little bit different. I have a directory called 4EPA, 12, 14, 18. That's when I sent the 30-box model to the EPA. I think you actually have a folder called 30box. You downloaded that one, is that correct?
But under that is the 4 EPA, so that when you get down low enough, we're the same.
Okay. What I'm going to do is, I'm not going to mess with this, okay? I want to keep my original clean. So I'm going to copy, and you can see I've done this once. I've got a 4 EPA copy here. So I'm going to take this thing, I'm going to copy and paste. And
You made a second copy of it.
I made a second copy, and we'll call this exercise 1. Okay, so here's exercise 1. Let's see something. I think we're going to be okay here. We're going to find out. I did this in the motel room, I guess Sunday night or something, and I didn't exactly finish, but we'll learn as we go along. I created an executable, which is this WQM. I use Portland Group Fortran on this very computer. When people in the EPA tried to run that on a whole lot of different Windows machines, they had a lot of headaches. So your executable, I took their water quality model and called it WQM underscore GNU because I think they used the new Fortran. I suspect, I hope, what do you have in your directories?
WQMEXE.
That's the only one you have?
There's a folder called exercise 1.
We get both, okay. All right, so
There's
you guys got
a file
exercise
called
one.
exercise 1.
Okay, let's give it a shot and see how it goes. A little trick about the model, okay. What we're going to do is the model is going to try to write folders into an outputs folder, and you don't have an outputs folder. So in Windows, what we want to do is go new folder, and we're going to call that outputs. Okay. You can actually, in the control file, you tell the model where you want to put the outputs. If the control file is set up to put most of them in a folder called outputs, so if you don't have that folder, as soon as you run the model, it's going to bomb out. Okay. So we're just going to see what happens. The other thing I'm going to do, just because this is the snapshot, that's the original snapshot from when I ran the model. So I'm going to rename that one. Okay, let me rename that original. Yeah, do it. So, okay, so we've got an outputs folder. We've saved that snapshot file, and away we go. What this exercise is going to be, the simplest one, this exercise is called How Long a Steady State. Okay? So what we're gonna do is we're gonna run the water. Now here's where we may have a problem, and I hope this works, but if it doesn't, because I don't know how you're gonna edit this. What we need to do is to change the control file. And what do we want to do? Here's the control file. The model is set up right now to run 365 days. So what we want to do, okay, this is over there on that screen, 300, you see TM end? Right here, TM end. That's the time end. So it starts at time 0 and it runs 365.01 days. We want to make that 3,650 days, 10 years. Oh, look at that. You didn't record me eating lunch? You don't have the beginning of this exercise. We're all so big. Okay, so I'm going to make that 3,650, and there's a couple of ways I can do that. Just by coincidence, there's a 3,650 sitting out there. So all you got to do is backspace to there. And we keep in mind that, remember, the control file is formatted. The words up there are, they show the fields, basically. And remember that we always want to, well, we're going to run just a little bit more than 3,650 to make sure that we complete the 3,650 days. That said, I'm going to save that file. Ready to go? I'm going to go slow, but is everybody who's trying to do it on Windows, are you ready to go? Everybody who isn't ready, raise your hand. Okay, so all we have to do in Windows, what's it? Did I see a hand? I see a hand. Okay, Jim saw a hand. That's okay. Take your time. I know this is when you go too fast.
I'm just trying to get the right folder here.
By the way, this, I think there may be one small difference I'm not going to worry about today, but the code that you downloaded, either the one that's in this folder is the exact code that the Bay program runs right now. So you have the latest Bay program code that's consistent in all regards with what they're doing.
Is that an example one? Example one?
Example one, or $30.
Okay.
Okay. So if all goes well, we go to our water quality model icon and double click, and it starts to execute. I was looking at this stuff being printed out and thinking, what the heck is that? And the Bay program told me this is what they got from me. And at least it shows you it's running. I realized what happened was when I was developing a sort of fast and dirty post processor for the class, I made the model print some stuff out, and I forgot to remove those write statements. But as I said, at the very least, while this is happening, we know that something's going on, so that's good, you know. And we need Jeopardy music or something. Well, this shouldn't take more than about a minute.
So if you're running it on the cloud, it would be the srun-n.
If that's the
Which one are we supposed to run?
I guess there are a lot of I think srun is one of the things you could do.
Right.
But I think what
Yeah, the one without GNU doesn't.
I think what John said yesterday was if you submit it to the queue, you're liable to have a long wait, even though this job only takes a minute or something. Well, we'll find out when Richard gets up here and we run it on the cloud. So hopefully everybody's got a model running or maybe even completed, right?
Success.
Excuse me? Okay. And I see I've got a problem, but that's okay. We'll, what you should have completed right now is a WQM_SNP.051316.
In the
Okay.
outputs.
Yeah. No, it's not in the outputs. It's in the same folder as your executable. Okay. The post processor, as it turns out, is hardwired to look at WQM_SNP.OPT. So I'm going to rename that. And I should have done that earlier. That's okay, just do it. So we're going to rename that, and we're going to post process it. The post processor that we're going to use is a primitive little thing that I wrote for this class, and it reads the snapshot file. I think I mentioned yesterday, and sort of analogous, what the process we're going through is analogous to what's done with the big model. Only with the big model, remember, you read the PLT file or the APL file. You don't look at the snapshot file. But for a class, we're going to read the snapshot file.
Will the program that reads the plot file will also read the snapshot file? Is
No.
the format the same? No.
Not at all.
Okay.
The PLT and the APL are in binary, the snap's in ASCII. So
I'm
there's,
sorry, will the program that reads the APL file also read the plot file?
I don't think so, but you could check. Okay, so now you've got a file, it's called read_SNP, okay? So let's double click and execute. And you got a little window and it says what variable. Okay, so Richard handed out, we've got 28 active state variables, I think. Richard gave a handout, a code between the state variable number, because this is looking for a variable number, and the variable name. So does everybody have that?
Yes.
Okay. So we're gonna tell it, I think salinity is variable 2. So let's tell it salinity. We're going to type into 2 and hit enter. And it comes back and says, what sediment variable? I'm going to say G2 nitrogen. What number is that? Is it 6?
G2, I will tell you. Temperature is 1, 4, 5, 6.
The G2. Oh, it's total. 7 POT.
Yeah.
Okay, this one is not looking for me.
Okay, we're going to
Actually,
go
the
to...
variable list, if this is
One
different than
moment.
what's being written out, it's not like the normal
Yeah.
flux model, Carl.
Oh, it's not OPT, not PLT. That's why it's.
Okay.
It does.
I think I spotted this when I did this exercise. So, okay.
Variable number 6 should be PLN, too.
Yeah. What will... Just because... Let's go over here for a minute. Let's go into source. You folks don't have to do this. You can just look at the screen for a moment. I'm going to go into the source code and I'm going to find... So what I've done, and like I said, all you have to do is watch.
Got it.
Okay. This is, I did this Sunday night. Why did I go into the code? Well, I'll show you a few things. There's the right statement for the APL file. And what we see is that if sediment diagenesis, do-do-do-do-do-do-do. Lord have mercy. All right. G2 nitrogen is variable 6. I did it Sunday. Let's stop there. Okay. Let's close that. So coming back to here, when it says what sediment variable, I'm going to say number 6, and I'm going to hit return. And so what it did, you now have a read snapfile.sed output, a sediment output, and a read snapfile.wq output. So those are, what we've done is this little primitive processor, we've told it, please spit out water quality variable 2, which is salinity, and please spit out sediment variable 6, which is G2 nitrogen. Okay, so there they are. Now, since we're doing this on a PC, all right, now we need to look at that file and see what's in it. And what I'm going to do is I'm going to use Excel because hopefully everybody's got a Windows. Even if you don't have a Windows PC, I hope you've got Excel. If not, maybe you've got something else. But at least let's open that file and let's take a look at it. So we go File. Let's see what happens here. Let's go File, Open. And you need to go to the whatever folder you have that read snap out in. So I'm going to try to find that folder. Go to here, go to here.
And you gotta change all Excel files to all files.
Excuse me?
You have to change all Excel files to all files.
Yeah, I've got to get...
You gotta get to the folder, but, right.
There you go, all files. So again, we're doing this in Excel, and because that file doesn't have an XLS, as Jim notes, if you want to find it, you need to make it in this little thing down here, all files.